Welcome to our exploration of one of nature's most formidable forces, hurricanes. Emerging from warm ocean waters, these massive storms grow with unmatched power, capable of unleashing devastation upon landfall. They remind us of nature's awe-inspiring, sometimes terrifying power. But what exactly is a hurricane? At its core, it's a storm of colossal energy, a complex system of swirling winds and rain that can extend hundreds of miles across. As we delve into this video, we'll explore these powerful phenomena, their origins, and the global threat they pose. We will study the hurricanes Helene and Milton that recently destroyed many human lives but granted us more insights. Understanding the mechanics of hurricanes helps us appreciate both their destructive potential and the vital importance of scientific knowledge in mitigating their impact. Join us as we uncover how these incredible storms are born, the science behind their formation, and the steps we can take to protect ourselves from their impending threat. Prepare to be captivated as we unfold the story of hurricanes, nature at its most raw and potent. The birth of a hurricane begins over expansive, warm ocean waters where nature's forces converge. It starts with clusters of thunderstorms, potent and scattered, waiting to transform into something greater. Guided by Earth's rotation, the Coriolis effect, these thunderstorms spin into a unified, swirling force. Combined with warm, moist air rising from the ocean's surface, they form a low-pressure system. This encourages even more thunderstorms to join, feeding the storm's growth. As conditions align, the storms join in a synchronized dance, multiplying in power. It's a delicate interplay of elements. Warm waters fuel the storm, rising heat injects energy. Earth's rotation provides direction and spin. Noticing the resulting rotation signifies the hurricane's birth. Understanding the beginnings of these formidable storms is key to predicting and mitigating their impacts. Reminding us of the powerful and intricate systems at work in our natural world. The life cycle of a hurricane is a fascinating yet daunting journey. It begins with a cluster of thunderstorms over warm ocean water. As these storms gather, the energy from the warm waters and the Earth's rotation gives birth to a spinning mass of clouds and wind, the early stages of a tropical cyclone. Then, the system enters a phase of intensification. Warm waters fuel this process, sometimes evolving the storm into a powerful and destructive force. As it moves toward cooler waters or land, the hurricane enters its final stage, dissipation. The loss of its heat source weakens it, often transforming it back into a series of thunderstorms. Various factors like ocean temperatures, atmospheric conditions, and other weather systems influence this cycle. Understanding this process is crucial for predicting hurricane behavior and mitigating their impact, reminding us of the delicate balance between nature's might and human preparedness. As our planet warms, the impact on hurricanes is unmistakable. Rising ocean temperatures, a consequence of climate change, act as powerful fuel, intensifying these formidable storms. Heat energy from warmer seas injects hurricanes with increased moisture and strength, leading to more frequent and severe events. Scientifically, each additional degree in sea temperature can heighten a hurricane's intensity, turning storms into potent destructive forces. This is a vicious cycle. As climates shift, the occurrence and potency of hurricanes may increase. Recent decades have already seen a surge in intense hurricanes leaving unprecedented damage. We're at a crossroads where addressing climate change is more pressing than ever. Understanding the link between warming oceans and hurricane strength boosts our ability to predict, prepare, and protect against these looming threats. Our journey through this narrative underlines an urgent call: can we stem the tide of change, or will we face stronger tempests ahead? In the dynamics of our oceans, two powerful forces significantly influence hurricane activity: El Niño and La Niña. In the vast Pacific, these phenomena shape weather patterns worldwide. El Niño, a warmer ocean phase, often suppresses hurricane formation in the Atlantic by warming the mid and upper atmospheres, thus stabilizing conditions. Conversely, La Niña, with cooler ocean temperatures, creates an environment ripe for hurricanes, offering reduced wind shear and cooler air that foster more frequent and intense storms. This oscillation doesn't just alter hurricane frequency but also their intensity and devastation. Understanding this interplay is vital for anticipating patterns, as each cycle can impact regions differently, from the Atlantic to the Gulf of Mexico. As we delve deeper, grasping El Niño and La Niña's subtleties is crucial to comprehending their broader impacts on our planet's weather systems. In our quest to counteract hurricanes, advancements in tracking technology offer hope. Cutting-edge tools now allow meteorologists to predict hurricane paths with remarkable accuracy, sometimes weeks in advance. Doppler radar and satellite imagery provide a detailed view of these swirling giants from their formation, monitoring their progress across vast oceans. Such foresight is invaluable, giving early warnings critical for securing lives and property. It's a race against time, and every second counts. Early warnings offer coastal communities precious time to prepare, minimizing loss and safeguarding the vulnerable. Today's technology means fewer casualties than in the past. From supercomputers processing atmospheric data to drones capturing storm currents, our arsenal against hurricanes is more advanced than ever. But will our technology keep pace as storms grow fiercer? Investing in further advancements is essential. In this ongoing battle with nature, technology is our strongest ally, providing both safety and hope against these natural giants. As we explore hurricanes, historical and recent case studies offer invaluable insights. Consider Hurricane Helene, a devastating tropical cyclone that caused widespread destruction and fatalities across the southeastern United States in late September 2024. It was the strongest hurricane on record to strike the Big Bend region of Florida, the deadliest Atlantic hurricane since Maria in 2017, and the deadliest to strike the mainland U.S. since Katrina in 2005. The storm caused catastrophic rainfall-triggered flooding, particularly in western North Carolina, East Tennessee, and southwestern Virginia, and spawned numerous tornadoes. At least 214 deaths have been attributed to Helene. This stark reminder highlights the inherent unpredictability in hurricane behavior and the necessity of preparedness. Conversely, Hurricane Milton in October 2024 allows us to explore various scenarios. He was an extremely powerful Atlantic hurricane which became the second most intense tropical cyclone ever recorded over the Gulf of Mexico, behind only Hurricane Rita in 2005. Milton formed from a long-tracked tropical disturbance that originated in the western Caribbean Sea and consolidated in the Bay of Campeche on October 5, 2024. 2 days later, the storm underwent explosive intensification and became a Category 5 hurricane with winds of 180 miles per hour. At peak intensity, it had a pressure of 897 millibars, sucking in air from around it while becoming the fifth most intense Atlantic hurricane on record. Though less powerful than expected at landfall, Milton took at least 10 lives, mostly due to the more than 30 powerful tornadoes announcing the storm's arrival, and left 3 million people without power, a catastrophic storm surge and up to 18 inches of rain. From rapid intensification in warm waters to drastic course changes due to shifting wind patterns, a hurricane's power and course can change rapidly. Through experience with these examples, we learn from past hurricanes, emphasizing the importance of robust forecasting and preparedness measures. Reflecting on storms like Helene and Milton urges us to remain vigilant and learn from history to build resilience. This understanding is crucial in confronting a future where such storms may grow even stronger and more erratic due to the changing climate. The vast expanse of our oceans conceals both beauty and potential devastation. Among these seas, areas like the Gulf of Mexico and the Caribbean face unyielding hurricane risk. Warm waters here breed massive storms, with high sea surface temperatures and low wind shear creating perfect storm conditions. In these regions, hurricanes are a constant threat, their geographical positioning along major storm tracks exposing them to frequent and sometimes devastating impacts. Understanding why these regions are so prone is crucial for preparedness and risk mitigation. Their vulnerability highlights the importance of climate science. With climate change amplifying storms, knowing high-risk areas becomes essential. Looking ahead, resilient infrastructure and robust evacuation plans remain critical for safeguarding these communities from hurricanes' relentless grip. Through understanding and proactive measures, we can better protect lives amid nature's wrath. Hurricanes wield extraordinary power, leaving destruction in their wake. As these storms make landfall, they unleash winds often exceeding 150 miles per hour, uprooting trees and flattening buildings. Yet the peril doesn't end there. Massive storm surges accompany these winds, pushing seawater miles inland, inundating coastlines, and transforming urban areas into waterlogged expanses. Alongside these surges, torrential rainfall can lead to catastrophic flooding, with some areas experiencing several feet of water in just hours, inflicting severe damage on homes and infrastructure. Beyond physical damage, the impact is deeply human, leaving countless families homeless and communities disrupted, compelled to unite in reconstruction. Such devastation underscores the fragility of human life against nature's raw force. Witnessing their relentless power and the marks they leave compels us to prepare and understand. This knowledge is vital to protect environments and communities from future catastrophic events. As we look to the future, it's clear hurricanes could intensify if current trends persist. Coastal cities, guardians of lives and livelihoods, must rise to these escalating threats. Strengthening defenses isn't just wise, it's necessary. From robust seawalls to smarter urban planning, these innovations safeguard our communities. Enhancing early warning systems is crucial, allowing precise forecasting to alert people faster, giving them time to prepare and evacuate safely. The technology empowering us today must evolve to confront tomorrow's storms, ushering in a new era of preparedness. By investing in research and innovative solutions, we can mitigate these ferocious storms' impact. As we close our journey through hurricanes' world, we're reminded of the urgent need for action. Facing this formidable challenge requires a global commitment, staying informed and proactive. Only then can we withstand intensified storms and secure a safer world for generations. If you appreciated this video, please give a thumbs up and subscribe for the next video about tornadoes, or comment if you have hurricane experience to share. Thanks for watching.